Hello friends, myself R.D. Mahajan presenting my video on Unit 3rd Linear Differential Equation of M2 Revision Part 2. First example, solve d2y by dx square plus y is equal to cosec x by method of variation of parameter. And therefore, here given differential equation, if we convert in terms of symbolic form, it becomes d square plus 1 into y is equal to cosec x. Watch the video up to end so that all things are clear to all of you. Auxiliary equation is here. D square plus 1 equal to 0. D square is equal to minus 1. Taking square root on both sides, we get D is equal to plus minus I. Square root of minus 1 is I. And here imaginary roots in the form of alpha plus minus I beta type. Roots are imaginary. And as roots are imaginary, complementary function is given by e raised to alpha x, e raised to 0x, that is 1. C1 cos of beta x, C1 cos of x, beta is here 1, and plus C2 sin of x. We call this equation 1. Then comparing the CF with assume CF C1 y1 plus C2 y2. Comparing these two equations, we get therefore y1 is equal to cos x, y2 is equal to coefficient of C2, that is sin x. Differentiating this with respect to x, we get y1 dash as minus sin x and y2 dash as derivative of sin x as cos x. And then we determine the value of a. It is determinant of y1 y2 and y1 dash y2 dash, determinant of these four values, and therefore substituting the values we get y1 is cos x, y2 is sin x, y1 dash is minus sin x, and y2 dash is cos of x. And then evaluating this second order determinant as usual technique, therefore it is cos into cos square x minus sin square x, minus and that minus it becomes plus sin square x, that is equals to 1. Generally this type of problem is asked for 6 marks. For getting this CF correct, you will get 2 marks. For obtaining the value of A, you will get 1 mark. Particular integral is given by capital U into y1 plus capital V into y2, where the value of u is obtained by integration of y2 into phi of x divided by a, and then its integration with respect to x. It is equals to with minus sign, and therefore substituting the value is minus integration of y2. Here the value of y2 is sin x. Phi of x means the right hand side of that given differential equation. It is cosec x, and divided by a. Value of a just we obtain as 1 minus cosec means 1 by sin. Sin and that 1 by sin get cancelled. We get only integration of dx, and integration of dx is minus x. This is the value of u. Then we try to determine the value of v. For finding the value of u correct, you will get 1 mark. Then v is equal to integration of y1 into phi of x divided by a and its integration with respect to x. And therefore, substituting the values, integration of y1 is cos of x or cos x, phi of x is cosec x, a is 1, and then its integration with respect to x, it is integration of cosec means 1 by sine, therefore cos by sine, it becomes cot x, integration of cot x is equal to log of sine x. For this v, another 1 mark. Then substituting these values in that pi, therefore pi is equal to, it is u into y1, u is minus x into y1, y1 is cos x, plus vy2, v is log of sin x, and into y2, y2 is sin x. We call this equation number 2. Then we combine this equation 1 and equation 2 to get the complete solution, and therefore the complete solution is Cf plus Pi. We get, therefore, substituting values of Cf and Pi, we get the complete solution for y as C1 cos x plus C2 sin x plus Pi minus x cos x plus sin x into log of sin x as the required solution obtained by method of variation of parameter. And for this last step, again 1 mark, therefore total 6 marks. Second example, solve differential equation x square dy by dx square minus 3x dy by dx plus 5y is equal to x square into sine of log x. If you see the terms carefully, this is the Coeff differential equation. It is in Coeff form. This is a linear differential equation with variable coefficient, first type. And to obtain the solution, we have to use the substitution log x as t or z, whatever new variable. Transferring this to other side, we get x is equal to e raised to t, and using the operator capital D for d by dt, we get, or we have, that value of x dy by dx as capital D into y, and value of x square d2y by dx square as d minus 1 into y. Substituting these two values here in this equation becomes d minus 1 into y minus 3 times x dy by dx is dy and plus 5y is equal to x square, but x is e raised to t, therefore square of it becomes e raised to 2t, and sine of log x, sine of t. Taking y common from this, we get d square minus d minus 3d, we get minus 4d plus 5 times y is equal to e raised to 2t into sine t, a new equation with y as a dependent variable and independent variable as t. It is linear in y. It is linear differential equation with constant coefficient. and therefore applying the steps to find the solution of this. Auxiliary equation is here, d square minus 4d plus 5 is equals to 0. Factors, real factors are not possible, therefore we find by formula. D is equals to minus b, minus of minus plus 4, plus minus root of b square minus 4 square 16, minus 4 times AC, A is 1, C is 5, and divided by 2A, A is 1. And therefore simplifying it, we get the value of D as 4 by 2, we get 2 plus minus 16 minus 20, root of minus 4, square root of 4 is 2 by 2, and root of minus 1 is I, and therefore roots are, values for D are 2 plus minus I, imaginary roots with alpha equal to 2 and beta equals to 1, and therefore as it is imaginary roots, complementary function is e raised to alpha x, but instead of x we have a new independent variable t, therefore e raised to 2t c1 cos of beta x, beta is 1, therefore c1 cos t, c2 sine of beta x, beta is 1 and x means t, and we call this equation 2. Be very careful, don't write in terms of x, because we are using a new independent variable t instead of x. If you write in terms of x, then it becomes a wrong one. For this conversion in terms of linear differential equation, we get 1 mark, including all the steps, substitution, then this conversion, and getting a new differential equation. Then for CF, 2 marks. 1 mark for finding the root and 1 mark for writing the equation. Then particular integral is obtained by inverse operator technique, 1 upon f of d. F of d is here, d square minus 4d plus 5, operated on right hand side term. Right hand side term is e raised to 2t sin t. And as per this case, we have to replace d by d plus a. A is here 2. And therefore it is equals to e raised to 2t first before the operator. D replaced by d plus 2, we get d plus 2 whole square minus 4 times d plus 2 and plus 5, which we have to operate on sin t. Then it is equals to e raised to 2t 1 upon. Simplifying it, we get d square expansion 4d plus 4, then minus 4d minus 8 and plus 5, operated on sin t. Then it is e raised to 2t as it is, no change, 1 upon, plus 4d minus 4d get cancelled, 4 plus 5 9, 9 minus 8 we get 1, and therefore remaining terms are d square plus 1, which we have to operate on sin t. This become a case of sin ax plus b for pi, and therefore as per that case we have to replace d square by minus a square. A is here, coefficient of t 1, replace it by minus 1, and therefore we get e raised to 2t 1 upon minus 1 plus 1, we get 0 into sin t, and as denominator becomes 0, case fell. And as case fell first time, next step is e raised to 2t as it is, no change, t into differentiating this with respect to d. Its differentiation is 2d, derivative of 1 is 0, and then operate it on sin t. it is t e raised to 2t by 2. 1 by d means the integration of sine. And therefore, integration of sine is minus cos. That term become minus t e raised to 2t cos t whole divided by 2. And we call this as equation number next third. Value of pi. Then 2 marks for this step, obtaining pi correctly. All this step must be correct, then only you will get that 2 marks. Then to obtain complete solution, combine CF and pi. Substituting the value of CF and pi, CF is e raised to 2t into C1 cos t plus C2 sin t, and plus pi minus e raised to 2t t cos t divided by 2. This is not the final solution because original variables are x and y, and here we are getting a solution in terms of y and t. Therefore, once again we have to convert t in terms of x. It is e raised to t is x, therefore it becomes x square. C1 cos of t is log x, plus C2 sin of t sin of log x, minus e raised to 2t, it is again x square, t is log x, cos of t cos of log x, and whole divided by 2. This is the required answer or required solution. Always write down the final step or final solution in terms of original variables. Original variables are here y and x, y dependent, x independent. Therefore, this is the last step or the required answer. And for this step, you will get 1 mark. And if you combine all this, total 6 marks. This is the scheme of marking, approximately. It may vary by 1 or 2%. Last example, solve differential equation d square plus 2d plus 1 into y is equal to e raised to minus x into log of x by method of variation of parameter. And as we require to solve it by method of variation of parameter, we try to apply the technique. Auxiliary equation is here, d square plus 2d plus 1 equals to 0. It is perfect square of d plus 1 roots are d equal to minus 1 and minus 1. Two roots real and repeated, and as roots are real and repeated, CF is given by C1 plus C2x multiplied by e raised to minus x. We call this equation 1. Taking it inside, we get C1 into e raised to minus x plus C2x e raised to minus x. Then comparing this CF with assumed CF, C1 y1 plus C2 y2. Steps remains the same, whatever the problem of second order linear differential equation. You have to follow the same steps. Then comparing, we get y1 as e raised to minus x, y2 as x into e raised to minus x. Differentiating this with respect to x, we get derivative as minus e raised to minus x. Differentiating it by product rule, we get y2 dash as first term x, derivative is minus e raised to minus x. Second term as it is e raised to minus x, and derivative of x is 1. E raised to minus x we can take common. Remaining terms are 1 minus x. And we try to find the value of that a as given by determinant of second order containing the elements y1, y2, y1 dash, y2 dash. It is determinant of. Substituting these four values, we get y1 as e raised to minus x, y2 as x e raised to minus x, y1 dash minus e raised to minus x, and y2 dash e raised to minus x multiplied by 1 minus x. Evaluating this second order determinant, this product e raised to minus x into e raised to minus x, it becomes e raised to minus 2x into 1 minus x minus, and this minus it becomes plus x e raised to minus 2x. From these two terms I can take e raised to minus 2x common. Remaining terms are 1 minus x and plus x. Therefore, plus x minus x get cancelled. We get 1 into e raised to minus 2x means e raised to minus 2x as a value of e. Pi is given by capital U into y1 plus capital V into y2, where capital U is given by or obtained by minus integration of y2 phi of x divided by e, and then its integration with respect to x. Substituting the values, we get y2 is x e raised to minus x, phi of x as e raised to minus x log x, and divided by e raised to minus 2x, value of e, and then its integration with respect to x minus e raised to minus x into e raised to minus x, it becomes e raised to minus 2x, cancel with this e raised to minus 2x, remaining terms are x into log of x. Integrating it by parts. First function as log x, as per LIT rule, log must be the first and x as second. We get minus first term log x, integration of x is x square by 2, then minus integration of derivative first, derivative of log x is 1 by x, and again integration of x square by 2, it becomes minus x square log x by 2 minus 1 by 2, x square divided by x, remaining is x, integration of x is x square by 2. From these two terms I can take x square by 2 common. Remaining is log x minus 1 by 2. Value of u. Then we find v is given by or obtained by integration of y1 phi of x divided by a and its integration with respect to x. Substituting the corresponding values, we get y1, the value of y1 is e raised to minus x, phi of x is e raised to minus x log x, and whole divided by e raised to minus 2x, the value of e, and then its integration with respect to x, it is equals to e raised to minus x into e raised to minus x, it becomes e raised to minus 2x, cancel with this e raised to minus 2x, therefore remaining term is log x, and its integration with respect to x. Therefore, to perform integration of this, we multiply it by 1 and then integrating it by parts. First term is log x. Integration of 1 with respect to x is x, then minus derivative of log x 1 by x, and integration of 1, it is x log x, integration of dx is x, and therefore we can take a x common from this. Remaining terms are log x as a value of v. For this step you will get 1 mark, and then substituting these values here in this pi equation, we get that pi as, substituting values of u y1 and v y2, we get pi as minus x square y2 log x minus 1 by 2 into y1 e raised to minus x plus v x log x minus 1 into y2 x e raised to minus x as equation number 2. Then combining this with Coeff to get the complete solution, and therefore the complete solution is Coeff plus pi. Complete solution is always for dependent variable. Here dependent variable is y. Coeff is c1 e raised to minus x plus c2 e raised to x into e raised to minus x, or we can write this form, one and the same, and pi is minus x square by 2 log x minus 1 by 2 e raised to minus x, and plus x into x, we get x square e raised to minus x multiplied by log x minus 1 as a required answer. Or required solution of that given differential equation by method of variation of parameter. And for this step, last step, 1 mark, total 6 marks. In this video, I have discussed 3 different problems. 2 problems on method of variation of parameter and 1 problem of Coeff's form. In my next video, I will discuss the problems on unit number 4, Fourier series, part 1. Therefore, if you like my video, please share it as well as subscribe to my channel, and to receive the notification for my all new videos, you have to press the bell icon. Thank you. Thanks for watching.